Bismillahirrahmanirrahim. Now we will talk about the properties of expected value. There are two major or main properties of expected value. The first one is that if you subtract the average or expected value from the given variable, random variable, and then again take the average of or expected value of that difference, then it will be equal to 0. Second one is that if you add a constant value, multiply a constant value with random variable x, and then add a constant as well, and then take the expected value, then it will be same as you multiply the expected value with that constant and then add a constant in it. So we can see this over here with an example. For example, we take the values of x are 2.15, 3.71, 1.56 and 4.22, and simply take the average of this by adding all these values and divide it by 4, which is equal to 2.91. Now if we subtract the average values from each value of x, then we get 0.7 minus 0.76, 3.71 minus 2.91 is equal to 0.8, 1.56 minus 2.91 is equal to minus 1.35, and 4.22 minus 2.91 is equal to 1.31. Now if you add up all these values, then it will give you 0, because the number of positive values will be equal to the number of or the value of negative values. So for example, whatever the value will be, 1.31 plus 1.8 will be same as 0.76 and minus 1.35. So in negative value of these two values will be same as positive values, so positive negative will be 0, and then of course you take average of it, divided by 4, will give you 0. So as you can see that this gives you 0. So the expected value gives you 0 because to take the average you simply add up these values, and the addition of these values will always be equal to 0. So therefore the average will also be 0. Here in for this property, you can see that again we have taken the same values. We have taken a is equal to 2 and b is equal to 3, simply multiplied a by x, and then added 3. So 2.15 multiplied by 2 gives 4.3, 3.71 multiplied by 2 gives 7.42, and so on, and then added 3 in each of these values, and then achieve the expected value. Again, to get the expected value, just simply add these values and divide it by 4, so it gives you 8.82. So now we'll get the same value 8.82 by this one as well, this method as well. So simply multiply, first of all simply take the average of these values of x, which is same as this one, 2.91, because the values of x are the same, and then then multiply it by a is equal to 2, so 2.91 multiplied by 2 give you 5.82, and then add 3, b is equal to 3 in 5.82 gives you 8.82. So you can see that this value which we have achieved over here is same as this value over here, which we have achieved using this method. So either you first multiply a constant by the value of x, and then add the value of add another constant in it, and then take the expected value, or just simply multiply the constant with the expected value and then add the constant value. It gives you the same result. Now we will try to understand variance and standard deviation. We describe an average as a typical value of a random variable. It is one number that summarizes the entire probability model. So the average value of random variable gives us the expected value, what we should expect in when we are going to perform the experiments. After finding an average, someone who wants to look further into the probability model might ask, how typical is the average, or what are the chances of observing an event far from the average? So after getting the average, the question is that, okay, this is the average. Of course, these are not the exact values or the probabilistic values, but they are average. This is an average value. But what is the probability that when we actually perform the experiment, that then the outcomes will be close or nearby this average value? So a measure of dispersion is an answer to these questions. If this measure is small, observations are likely to be near the average. A high measure of dispersion suggests that it is not unusual to observe events that are far from the average. So the variance of random variable x describes the difference between x and its expected value. This difference is derived random variable y. Again, this the difference what we get between the expected value and the random variable is by itself is a derived random variable, and if we take the expected value of y, it will be 0, as we have seen over here, that if you have got variable x and if you take this expected value, subtract expected value from it, and then again take the expected value or average value of that, it will give you 0. And the reason I have explained you that because the total values of plus and minus will be same, and they will cancel out each other. So therefore EY provides no useful information, but squaring the EY gives us variance. So for what we do is that we square all these values, minus 0.76, 0.8, minus 0.3, 1.35 and 1.31. If we square these values, then it gives us variance. The reason we square them, because to remove these minus signs, so all the values will become positive, and of course in that case when we will take the average, then it will not be 0. It is useful to take the square root of variance, because sigma x has the same unit as x. Now the thing is that when we square these values over here, then we cannot compare these squared values directly with the with x, because these are squared value. But this average value over here will be squared one, and here we have got the actual values have got some unit, of course they are not squared values. So the units of the variance are squares of the units of the random variable. Thus sigma x can be compared directly with the expected value. If you want to compare this standard deviation, that can be directly compared with the expected value, but this variance cannot be compared with the expected value.